Risk analysis is a critical component of supply chain risk management because it enables organizations to evaluate uncertainties systematically and prioritize response efforts. The objective of risk analysis is to determine the likelihood that a risk event will occur and assess the magnitude of its potential impact on organizational objectives. Effective risk analysis supports informed decision-making, resource allocation, and contingency planning. Once risks have been identified and categorized, organizations analyze them using qualitative or quantitative techniques depending on the availability of data, the complexity of the risk, and the importance of the decision being made. The resulting insights help organizations focus attention on the most significant threats and opportunities while improving overall supply chain resilience. Qualitative and quantitative risk analysis techniques serve different purposes and are applied under different circumstances. Qualitative analysis relies on expert judgment, experience, interviews, workshops, risk rankings, and descriptive assessments to evaluate risk severity. These techniques are particularly useful when data is limited, risks are difficult to quantify, or rapid assessments are needed. Quantitative analysis uses numerical methods, statistical models, probability calculations, and financial estimates to evaluate risks more precisely. This approach is appropriate when sufficient historical data exists and decisions involve significant financial or operational consequences. Many organizations use qualitative methods initially to prioritize risks and then apply quantitative techniques to analyze high-priority risks in greater detail. A common approach to evaluating risks involves assessing both probability and impact. Probability measures the likelihood that a risk event will occur, while impact assesses the potential consequences if the event happens. Organizations frequently use probability impact matrices to visualize risk exposure and prioritize management attention. Risks with high probability and high impact are typically classified as critical and require immediate action. Low probability, low impact risks may require only monitoring. The matrix provides a consistent framework for comparing different risks and communicating priorities across the organization. By combining likelihood and consequence assessments, organizations gain a clearer understanding of overall risk exposure and can allocate mitigation resources more effectively. The quality of data used in risk assessments significantly influences the reliability of analysis results. Poor quality data can lead to inaccurate risk ratings, ineffective mitigation strategies, and poor decision-making. Organizations therefore evaluate data sources based on accuracy, completeness, consistency, timeliness, relevance, and reliability. Historical records, supplier performance data, financial reports, market intelligence, and operational metrics are common sources of risk-related information. When data limitations exist, assumptions should be documented and uncertainty acknowledged. Risk managers often combine quantitative data with expert judgment to improve assessment quality. Ensuring high-quality information enhances confidence in risk evaluations and supports more effective planning and response activities throughout the supply chain. Probability distributions provide a useful method for representing risk because they demonstrate that multiple outcomes are possible rather than a single fixed result. Instead of assuming one forecasted value, probability distributions show a range of potential outcomes and the likelihood associated with each. This approach helps decision-makers understand uncertainty more realistically and evaluate the potential variability of future events. Supply chain applications may include demand forecasts, lead time estimates, transportation costs, commodity prices, and project completion dates. By visualizing possible outcomes through probability distributions, organizations can prepare for a broader range of scenarios and make decisions that are more resilient to uncertainty and unexpected changes. Expected monetary value (EMV) is a quantitative risk analysis technique used to estimate the financial impact of uncertain events. EMV is calculated by multiplying the probability of a risk event by its associated financial consequence. For example, a 20% chance of a $100,000 loss results in an expected monetary value of $20,000. When evaluating mitigation options, organizations compare the cost of preventive actions with the reduction in expected losses. A mitigation strategy may be justified if the savings generated exceed the implementation cost. YIMBY provides a structured method for evaluating alternatives and supports economically rational decision-making when balancing risk exposure against the cost of risk management initiatives. Sensitivity analysis and simulation techniques help organizations understand how changes in key variables affect outcomes. Sensitivity analysis examines how individual factors influence results by changing one variable at a time while holding others constant. This approach identifies the variables with the greatest impact on risk exposure and performance outcomes. Simulation techniques, such as Monte Carlo analysis, evaluate multiple variables simultaneously across thousands of possible scenarios. Simulations generate probability distributions for outcomes and provide deeper insight into uncertainty and variability. These techniques are especially useful for complex supply chain decisions involving multiple interacting risks. Together, sensitivity analyses and simulations improve forecasting accuracy, risk evaluation, and strategic planning effectiveness. Organizations generally respond to risks using 4 primary strategies: accept, avoid, transfer, and mitigate. Acceptance involves recognizing the risk and taking no specific action beyond monitoring. Avoidance eliminates the activity creating the risk. Transfer shifts responsibility to another party through insurance, contracts, or outsourcing arrangements. Mitigation reduces either the likelihood or impact of the risk through preventive measures. Risk response planning is the process of selecting, documenting, and implementing these strategies. Effective plans distinguish between preventive actions that reduce risk before it occurs and contingent or corrective actions activated after an event occurs.